Hi everyone, welcome to the dreaded number 48 from section 7.2, addition and subtraction identities. In this video, we're going to go ahead and prove that the tangent of a plus b divided by the tangent of a minus b is equal to the sine of a times the cosine of a plus the sine of b times the cosine of b, all over sine of a times cosine of a minus sine of b times cosine of b. So in order to solve this problem, I will warn you it's going to take some time, so please make sure that you have been fed and hydrated, and that you also have some blank paper in front of you so that you can follow along and take notes. The struggle with these problems is trying to figure out where to begin. And to be honest with you, I made the error of starting on the right-hand side when I first tried to start this problem. It looks very similar to our sum and difference identities, but the tip-off that we can't do that is notice that the angle A is on one side of the addition sign and that the angle B is isolated on the other side, where if you take a look at those sum and difference identities that we have, they're actually paired together. So you would have an A and a B on the left and an A and the B on the right side of that plus or minus sign. So because of that, I am going to say I'm going to start manipulating the left-hand side, and I'm going to make it look like this right-hand side. So this is going to be my goal. Okay, so to begin, I'm going to rewrite my problem. So I'm going to do the tangent of a plus b all over the tangent of a minus b. And I'm going to use what I know about tangent. So I'm basically going to start expanding this out. So the tangent of a plus b is the same thing as the cosine of a plus b. And I also know that the tangent of a minus b is going to be the sine of a minus b all over the cosine of a minus b. Okay, so now what I'm going to go ahead and do is I'm going to fix that complex fraction that I'm looking at. So I'm going to rewrite this. So instead of having the division bar, I'm going to use the division sign. So we'll have the sine of a plus b all over the cosine of a plus b divided by sine of a minus b all over the cosine of a minus b. This, we can now use what we know about multiplying with fractions. So we'll have the sine of a plus b all over the cosine of a plus b times the reciprocal. So that's going to be the cosine of a minus b all over the sine of a minus b. So I'm going to go ahead and rewrite that down on another line. So we really have the sine of a plus b times the cosine of a minus b all over the cosine of a plus b times the sine of a minus b. Okay, so at this point, please note that from the step that I have written in blue from our previous step, nothing has changed. I've just written it all over one division bar. So at this point, I'm going to have to expand this out. So I'm going to use my sum and difference identities here. It's not going to be pretty. Make sure that if you are following along that you probably start on a brand new line. So here we go. Sine of a plus b. This is going to break into the sine of a times the cosine of b plus the cosine of a times the sine of b. That's just one of them. The next one, we'll do that in green so we can see it a little bit more. We're going to take a look at the cosine of a minus b. This is going to be the cosine of a times the cosine of b plus the sine of a times the sine of b. Okay? Now, we're going to go ahead and do the cosine of a plus b. That's going to become the cosine of a times the cosine of b minus the sine of a times the sine of b. And lastly, we're going to do the sine of a minus b. That's going to be the sine of a times the cosine of b minus the cosine of a times the sine of b. This looks terrifying, probably. So I'm going to move this up so we have a little bit more room. I'm going to leave that there so we can see that. I'm also going to get rid of any stray marks just to prevent any potential confusion that I might cause if I left them there. So now what we have is, notice that you have two terms in each case. So I have essentially like a binomial. So notice that this is one term and this is one term, just for example. I can actually do a massive FOIL in the numerator and in the denominator. So at this point, it's going to get real fun and real interesting real fast. So I'm just warning you about that now. So here's what we're going to do. We're going to FOIL the sine of a cosine b and cosine a cosine b. So you're going to get the sine of a, or actually I'm going to write this in a specific order, everyone. So I'm going to write my cosines first, followed by my sines. So if you take a look at that product between the two that I have outlined here, so if you take a look at, whoop, undo, put that back. If you take a look at this term times this term, I'll have a cosine of a cosine squared of b, because I do have a cosine of b in both terms, times the sine of a. Okay. I'm going to continue to map this out. What I suggest doing is pausing this video and trying to do the factoring, or sorry, the FOILing on your own. So as I continue, so I'm going to now go to this term. This is going to give me plus the cosine of b, the sine of a squared, the sine of b, and now we're actually going to go ahead and FOIL the next part. So this is going to be plus the cosine squared of a times the cosine of b times the sine of b plus cosine of a, just scoot this over a little bit so I can fit that all in there, cosine of a sine of a sine squared of b. Okay. Put that back and center it. All right, that was just the numerator. Look at that. That thing is huge. So we're going to go ahead and now FOIL out the denominator. So we'll start off here. So this is going to give me the cosine of a, the cosine squared of b, sine of a. So again, I'm just choosing to write it in this particular order. I'm putting all my cosine a's, cosine b's, sine a's, sine b's. So now let's come over here, and that's going to give us minus cosine squared of a, cosine b, sine of b. And now we're going to continue. I'm running out of colors, which is kind of just hilarious. All right, so now we're going to go ahead and distribute here. So this is going to be minus cosine of b sine squared of A sine of B, and then plus cosine A sine of A, and then sine squared of B. Okay, so that is our huge, massive, nasty-looking FOIL. It doesn't look like, it looks like there's so much information in there that there's not a whole lot that we can do with it, but I do promise that there is more that we will be able to do with it. So what I want us to notice here, and again, it might be a little bit difficult, is I'm going to rewrite this, okay? So I'm going to notice here that this term here and this term here. Notice that you have, oops, let me pull that down and erase that. Notice that each one has a cosine A and a sine A, as well as a cosine squared B and a sine squared B. Your Pythagorean identity is basically coming in here to save the day. So I'm going to go ahead and, what I have circled in red, I'm going to go ahead and rewrite next to each other. So again, I'm going to rearrange this. So I'm going to do cosine of A, sine of A, cosine squared of B, plus cosine of A, sine of A, sine squared of B. I'm also going to note the following, that I also have, take a look at the other two terms here. Notice that both of them have a cosine B, sine B, and they also have a sine squared A and a cosine squared A. So I'm going to go ahead and just rewrite these in. So plus cosine of B sine B, sine squared of A, plus cosine B sine B. I'm running into my little keypad. I don't think you guys can see it on your side. I have like a little palette of color, so I gotta move it out of the way. Cosine squared of A, and I don't need that line. Okay, clear up my stray marks. All right, we're 13 minutes in, everyone. I apologize that it's taking this long. Okay, so now, but once we're done with this step, it's all going to kind of fall into place. Okay, so now we're going to see something similar happening here. So in the denominator. So notice here I do have a cosine squared B, and sine of A. Well, I also have that happening over here. So if we went ahead and kind of put this in, we would have cosine of A, sine of A, cosine squared of B, plus cosine of A, sine of A, sine squared of B. Okay, and now, last one, we have these two terms. So we have minus cosine of B, sine of B, cosine squared of A. So I'm just rearranging those those factors within the term. Minus cosine of B, sine of B, sine squared of B, or sorry, of A. Okay, so now we can actually do some factoring, okay? So here's what I'm saying. I see that I have a cosine of A, sine of A in this term. So I'm going to go ahead and factor it out. That's going to leave me with a cosine squared of B plus a sine squared of B. So if you didn't understand why I was saying Pythagorean identity, hopefully it's a little bit more apparent here. I'm also going to go ahead and do the same thing here. So I have plus cosine of B, sine of B, and what I have left over is sine squared of A plus cosine squared of A all over. Again, we can factor this out, so we have cosine of A, sine of A, with a cosine squared of B plus the sine squared of B. And then lastly, we can pull out a negative sine or cosine of B, sine of B, minus cosine of B, sine of B, which is going to leave you with a cosine squared of A plus a sine squared of A. Okay, so let's pull all that up and let's kind of get rid of some of the scary stuff because there's a whole lot of writing that we just did. Okay. So now the fun stuff can begin because our Pythagorean identity is going to say that's going to simplify to a 1, this simplifies to a 1, that becomes a 1, and that becomes a 1. So what are we left with? We're left with the cosine of A, sine of A, plus the cosine of B, sine of B, all over the cosine of A, sine of A, minus the cosine of B, sine of B. Okay? And that actually is what we're looking at. I just need to rearrange it to get us back to our original problem. So I can use my commutative property and switch these two positions. So this is the sine of A times the cosine of A. I can switch these two positions, and this is the sine of B times the cosine of B. So at this point, I'm just doing cosmetic surgery here. I can switch these two. So this is the sine of A, cosine of A. And then I can swap these two, minus sine of B, cosine of B. And there you have it. This is it. If you made it through this almost 20-minute video, give yourself a pat on the back.